Right, so this is another of those prove the equality questions in trigonometry. So the question is, prove that 1 minus sine A divided by 1 plus sine A, this whole thing in under root, is equal to secant A minus tan A. So this is what we are supposed to prove, right? So let's start with the left hand side. So the left hand side is 1 minus sine A divided by 1 plus sine A, this whole raised to the power half, right? I mean, this is the same thing as writing under root over here. So what I can always do is I can always multiply and divide this expression with something. So if I multiply and divide this with 1 minus sine A, right? So this is effectively equal to 1, right? So I'm really not changing the value of the expression, but I'm just changing how it looks. So this whole raised to the power half, right? So square root of this. So I can always do this. And so what does this mean? So this becomes equal to 1 minus sine A whole square divided by 1 minus sine square A, right? This whole raised to the power half, right? And what's 1 minus sine square A? Well, 1 minus sine square A is just equal to cos square A. So this becomes 1 minus sine A whole square divided by cos square A, this whole thing raised to the power half. So now what do we have? So we've got two square terms. So we basically have a term like x square by y square under root. So this becomes equal to x by y, right? So you got two square terms on the inside, so this becomes equal to x by y. And so therefore this term becomes 1 minus sine A by cos A, which is equal to 1 by cos A minus sine A by cos A, which in turn is equal to secant A minus tan A. So that was the question. So this was quite easy to prove that under root 1 minus sine A divided by 1 plus sine A is equal to secant A minus tan A. So that was the question, and that's how it's done.